So before I go into the details, what makes me qualified to be able to talk about this? So I'm a founder and CEO of Zaloni, and we help a lot of our customers with their big data and data lake implementations as they deploy this in a greenfield manner or move some of the legacy data platforms. And what we're seeing as an increasing trend is either it's a cloud-first discussion where customers are thinking of building these new next-generation data platforms in the cloud, or they're thinking of moving these systems from their existing on-prem enterprise environments into the cloud. So we'll talk about some of the trends and patterns that we're seeing. But before that, these are some numbers from IDC Research, where there is an increased spending in terms of enterprise infrastructure, where things are getting deployed in cloud. And I'm not just talking about small and medium-sized companies. I'm talking about large enterprise companies that are onboarding public cloud providers as their core IT infrastructure or as their core IT platforms, where they're building apps on top of these platforms. So these are some of the numbers from IDC Research, where they say by 2018, 60% of all the expenses on IT infrastructure will be in cloud environments. And I mean, this is underscored by recent announcements. A lot of you may have seen last week one large database and IT infrastructure vendor, their focus about kind of going after some of the public cloud providers and their focus in terms of how they get part of this share of wallet from the CIOs of large enterprises. So what are some of the drivers to build these data platforms in the cloud? So I've bucketed them into three different categories. One is more focused on the infrastructure drivers, where customers are thinking about an agile infrastructure, right? So their existing IT organizations are not able to provision the systems. They're not able to add new capabilities as quickly as they would like, right? So that's why they want to kind of go into a cloud environment where these things are turned on with a swipe of a credit card, for example, right? So we have a customer where they have a Hadoop environment on-prem. To add a new server to that Hadoop environment, it takes them 6 months, going through the IT procurement process and onboarding and all the things. And then they wanted to enable one of their data science teams. They went to one of the public cloud providers and stood up a cluster in less than 2 weeks. So that's kind of type of difference we're talking about. Excuse me. The second driver is, of course, cost. Rather than having a huge capital investment, you're able to use things on demand and build things as you need based on your application and enterprise requirements. And then along with that comes elasticity. So you have a pretty good handle on how much infrastructure you need for both compute and storage as your needs grow. And then there are various other reasons and things like that. So the other key criteria we see is data locality. And I'll tell you what that means. So we have customers where now they are deploying data platforms at a global scale, right? So they don't just have a data center in North America and bringing in data from all these different environments that are being deployed worldwide. So there are certain requirements when you have such a use case. You need to think about some of the in-country requirements where the data that is generated in a given country needs to stay in the country because of regulatory and other compliance requirements. The other fact is also data gravity, right? So if you're generating a lot of data in a given geo, you may want to run the analytics in a much more decentralized way to be able to get the insights within that geo instead of hauling all the data to one big data center in a centralized manner. A good example is a customer of ours has all these smart vending machines deployed worldwide, right? And one of the main things they're trying to drive out of it is supply chain and logistics, analytics for supply chain and inventory and things like that. So instead of them bringing in all the data from these smart vending machines back to a data center in North America, for machines that are deployed in China or Japan, it only makes sense to be able to do the decentralized analytics in those geos to be able to get a view of what supplies are needed in which stores and be able to push it down from those geos instead of kind of bringing it into one centralized platform. And similarly, you have new requirements. So you have new applications, new use cases popping up every time. And for each use case, you don't want to spin up a whole bunch of capital and infrastructure costs to be able to kind of set up these data environments. So how do you do that more efficiently in a cloud platform? So these are some of the key drivers that we see as customers are starting to think about data lake or data platforms in the cloud. And of course, we hear this word quite often these days, IoT. So sensors and machines generating data that need to be analyzed in a timely manner, in a time series manner. How do you do that more efficiently? So we see a lot of use cases where cloud and cloud-based infrastructures are being used, are being driven by these IoT type of use cases. So this is a study done by Gartner where they published a report last year, and they find that even for Hadoop-based deployments, majority of the action is in the cloud. So here you can see that 23% of the respondents are adopting a cloud-only strategy, which means as they're building out these platforms, they are getting built only in cloud. They don't even have a legacy on-prem environment. 29% have hybrid, which means they have some on-prem clusters, and they're also starting to spin up these clusters in the cloud. And then 32% have on-prem only because of security or sensitivity or some other requirements where they are not making that jump yet to the cloud. But more and more customers are moving towards the right-hand side, if you will. So what are some of the use cases? So I put together one of these use cases that we implemented last year for one of our customers. They have a fleet of around 25,000 vehicles. And each vehicle has an onboard unit that reports some of the vitals about that vehicle, like what is the location with lat long, what are some of the other parameters that needs to be monitored. And the use case here is that they want to calculate the idle time of a vehicle so that if the vehicle is idle for more than 20 minutes in a given location, then the dispatcher needs to be alerted so that they can contact the driver and figure out what's going on and if they need to plan a workaround and things like that. But they want to do it in a smart way. So they want to correlate the vehicle data with weather data, with traffic data, and other data sets so that they're making some smart decisions in terms of what needs to be done as an alternative when a vehicle is idle for a period longer than the threshold, right? So this is what it looks like in terms of an implementation. And our previous speaker already talked about a lot of these frameworks, so I'm not going to go into those in details. But the fleet that has 25,000 trucks are sending data points every 30 seconds. So that those data sets are coming in, and there are collectors that are being deployed in the cloud that are receiving those data points from the trucks. And then they're putting it into a distributed message queue based on Kafka that you previously heard. And then what we're doing is we're implementing a consumer out of the Kafka topics based on Spark streaming so that you keep the data in a micro batch kind of manner and you're doing things much faster. And it's doing the implementation of the idle time calculation, and then it is pushing events that needs to be notified into an H-based data store. And then on the consumption side, you're building an app using Spring framework, using AngularJS, so that the dispatchers have this app in their desktops, and they get alerted as part of idle time alerts that are being generated as part of this end-to-end pipeline. So there are a couple of things that are significant here. So first is the data is very time sensitive. So as the data gets generated, you need to process the data quickly. You want to do it in a scale out manner, and you want to use some of the auto scaling capabilities because there may be some spikes because a lot of trucks in a given area are sending data at the same time, and you need to be able to handle loads like that. You also want to not have a persistent layer of compute if you can avoid, right? Because you could do these calculations and you can then save the data in a persistent layer for further downstream processing for analytics and things like that. But whatever is needed right now is the idle time calculation and generating these alerts. So think about those kind of patterns as you are building these cloud infrastructures or cloud platforms. Sorry. One of the common use cases that we see or discussions that we have right now is data lake in the cloud, right? So customers are starting to build these large scale out data platforms, and what does it look like when they're starting to build these platforms in the cloud or using a combination of on-prem and the cloud. So this is a reference architecture that we use where you have different types of data that are being generated. You need to bring in the data into the data lake, which is the box in the middle. And when we think about the data lake, we try to partition it into different zones. So we try to think about a transient landing zone where the data may be coming in, and you may need to do some treatment of the data to make it consumable in its raw format, where you may need to tokenize or mask some of the sensitive attributes, for example. And then we think about doing data standardization, data validation, and those operations to create refined data sets that you again make consumable out of the data lake. And then we think about having a function where data stewards or subject matter experts within the organization are defining some of these data sets as trusted data sets, right? So that they can be widely used in a standard way across the organization. And then there is a need to have a place for doing ad hoc exploratory analytics, and that we call the discovery sandbox within the data lake. So that's kind of the reference architecture, and to enable such a architecture, you do need to have capabilities with metadata management, with data cataloging, with data quality, security, and governance and entitlements. So think about this as the architecture. Now, how would you take this architecture and deploy it in the cloud is what we're going to talk about in the next few minutes. So there are a bunch of different options. So you need to think about what would it look like at the infrastructure layer, which means what are your options for keeping the data in cloud-based storage platforms. And there could be different ways of doing that. There could be ways of storing the data in a block storage platform versus a cheaper object storage platform versus keeping them as files and treating them as files. So you need to think about what are some of the requirements in terms of redundancy, in terms of availability across different zones, and so on and so forth. So similarly, you need to think about compute layer. So when you think about the compute layer, you need to think about whether you're going to have a persistent compute layer where the servers are up and running all the time versus a transient compute layer where if you have specific times during the day when you need to process the data, maybe you can bring up the compute layer and you can do the processing and then you can shut down the compute layer, right? So as you go into these cloud-based architectures, it's important that you map your requirements into some of these infrastructure platforms that are available. And then as you mature along the cloud deployment model, we see a lot of our customers think about cloud native services. How do you leverage them? So these could be managed data warehouse platforms or managed messaging systems or managed Hadoop clusters so that you're using it more at a platform as a service layer than infrastructure as a service layer, right? So then most of the cloud providers offer you these options. And then as you think about this, you always need to think about how do you do data management, how do you do governance, how do you define entitlements on the data, how do you do tokenization and masking of the data, and so on and so forth. So I put together what we think as the cloud data lake maturity model. So we see some of our customers just trying to take whatever they have in their on-prem and replicate in the cloud. So that is basically the first step we consider as a movement to a cloud infrastructure. So that's a lift and shift of your on-prem Hadoop cluster into a similar cluster that is in the cloud. And then as you start leveraging some of the platform as a service layers, you may think about cloud native features. What does that mean? That means leveraging some of the object stores that are available, leveraging transient compute platforms and event-based systems or serverless computing platforms in the cloud environment. And I'm not saying that this is how you have to mature. I mean, you could start as a cloud-first strategy, start with cloud-native features. You don't have to have an on-prem cluster and do a lift and shift. That actually gives you some advantages where you can leverage some of the innovations that are going on. But I think the third one is most important. And this is where we see a lot of CIOs and other technology leaders getting worried and making sure that they have a strategy for this. So you don't want to be tied to one cloud service provider. You want to be cloud service provider agnostic in the long run. Why? There are different reasons. One of our customers needs to deploy in different geographies, right? In different geographies means different countries, and the same cloud provider may not have presence in all those countries. So they may need to go across multiple cloud providers to have wide enough geographic coverage. We recently heard from a cloud service provider where they're saying that you can keep data in wherever you want, but we have the best analytics offering that you can think of. So if you are focused on analytics and some of the things that the previous speaker showed you with AI and other things, you may want to think about where are these features available? How can you quickly enable and build applications using some of the analytics as a service platforms that are available? So as you build your cloud-based data platforms, I tried to list down a few things in terms of what are some of the patterns and anti-patterns, right? Things you need to think about as you build these cloud data lake platforms, and things you need to avoid so that you don't make some of the mistakes in your as you build out these platforms. So first of all, you need to think about how do you take advantage of the elastic compute and the optimized storage in these cloud providers. How do you take advantage of the cloud? How do you have them do the heavy lifting of these environments instead of you trying to build these on your own? And then how do you leverage the cloud storage platforms and have a data lifecycle management policy that governs how the data needs to reside from a fast tier storage to a medium tier storage to a kind of archive storage platform within the cloud environments. And then you also need to think about some of the event-based systems, because systems are becoming increasingly continuous instead of batchy. So data comes in all the time, and you need to process data as it comes in instead of just processing them at discrete intervals, right? So how do you leverage some of the event-based systems that are available in these cloud service providers so that you can build these applications on top of it? Some of the anti-patterns of building these cloud data lake environments: avoid trying to do a lift and shift, where you're forklifting whatever you have in your on-prem and trying to deploy it in the cloud. You need to think about how can you kind of map it to some of the cloud native features. Also avoid unmanaged and unmonitored persistent compute layers, so that they're just up and running without you having any knowledge of how much they're being used and why they're up and running. And then also, we see that a lot of customers try to build their cloud infrastructures to serve the peak loads but you can actually take advantage of some of the auto-scaling features in these cloud providers so that you don't deploy a peak load serving system at the beginning. You just start with whatever you need at that point of time and let some of the auto-scaling features come in and help you in that regard. So governance and security considerations are paramount as you build these cloud and multi-cloud environments. So you need to think about repeatable ingestion of the data from various sources. You need to have visibility and management of the data from a governance standpoint, where you have proper security and access control. You have the data encryption at rest or in flight. And then you need to capture operational metadata across different instances of these clusters. So clusters may come up and down because you have them as transient, but your metadata needs to be persistent across these instances, right? So what data do you have in your storage layer? Because now you're separating your compute and storage, right? So as your compute layer comes up and down, you have the storage layer that is persistent, and you need to have metadata about the storage layer so that you're able to leverage that for the next instance of the compute that comes up. And as part of this, to kind of be able to onboard new data sets, you need to think about building repeatable or reusable data pipelines for doing data validation, standardization, enrichments, and so on and so forth. Sorry. All right, so just to kind of wrap up, what are some of the things you need to think about as you try to select your cloud service provider? So you need to think about what are some of the capabilities they have at the infrastructure as a service layer. So whether you're trying to leverage a bare metal type of infrastructure, some cloud providers do have that offering, versus a virtualized, containerized type of environment. You need to think about what are they offering at the platform layer with managed data platforms at the Hadoop layer, like managed Hadoop clusters, or managed event-based messaging systems, managed data warehouses, or MPP data stores. You also need to think about what higher level services you're trying to leverage. So for example, a lot of the cloud service providers are coming up with analytics as a service offerings, right? So as you're trying to build analytical applications, can it map to some of the things that they are offering so that you don't have to do the heavy lifting in terms of the algorithms and the implementation of the algorithms. And then you need to think about geographical coverage so that you can cover any in-country data requirements and so on and so forth. And last but not least is the cost and total cost of ownership. So you need to think about, even though I'm using object store, how does it compare to, say, an ephemeral storage that is part of my cluster that I'm trying to replicate based on what I have on-prem, and be able to get a sense of what the total cost of ownership looks like as part of the cloud environment. All right. So this is a chart to kind of wrap it up. I put together. I'm not trying to kind of talk about any specific cloud service providers, because this is a talk about what are some of the options that you should have and what are some of the patterns. But just to kind of give you a view from the top 3 public cloud providers, Amazon, Microsoft, and Google, what I'm trying to show you here are options at different layers if you are using, say, their specific services versus you're using a Hadoop ecosystem-based set of frameworks to build your data lake environments, right? So you have the infrastructure layer, let's say, from these cloud providers. Then if you want to build the data processing platforms, from Amazon, you have EMR. Microsoft offers HD Insight. Google has Dataproc, where it is a managed instance, versus you can bring your own Hadoop distribution to build your own clusters, right? Then if you're thinking about stream processing, you have various options from Amazon, from Microsoft, from Google. And then you can also bring in your own frameworks, whether you're using Spark Streaming or Storm or Flink, And then at the analytics layer, these cloud service providers are starting to offer analytics as a service. So you have machine learning capabilities from Amazon, you have Cortana Analytics, you have cloud machine learning from Google, and versus you can bring in your own frameworks and build your own analytics algorithms in the cloud. So that's it in terms of the presentation. So we are in booth 644, so if you want to stop by and have more discussions on this, and also we're giving out some t-shirts. All right, thank you.